All right. Chapter 7. Scatterplots. Association. And correlation. Scatterplots.
Did we do a scatterplot in Cherith or something?
Yeah, we did them in algebra too.
Oh, that's why it's not.
Are the best way to see relationships in data. Look for possible association. I cannot spell. This is a problem. When examining a scatter plot, look at direction. Okay, if it's negative or positive. Look at shape. It's linear, curved, random, etc. And look at strength. If it's strong, weak, moderate, and mention outliers.
Is the strength like how drastic it changes? So like this would be weak and that would be strong.
I spelled plot with 2 O's.
And another thing that will also go in with that, and you'll see it when we do a picture in a minute, is that if it's like all the dots are like really tightly packed together, we say that it's strong. If they're packed together but not completely, we usually say moderately strong, okay, or weak, depending on what the case is. Okay, and then if they get really, really spread out, we would say it's like weak. Okay, so we used like descriptors when we're talking about our data. All right, so you need 2 plots drawn. Leave space to write between them.
Oh, I get it. Sorry, I really genuinely heard sawtooth clock. Like a clock. Oh, well. Not clock.
All right, so this first one. Something like that.
I was getting ready to ask if you're pulling up. Thinking
And it
clock.
doesn't have to be perfect, just and I'll let y'all draw those, and then I'll write what I'm going to write beside each one of them.
Are you gonna describe them?
Huh?
Are you gonna describe them?
Sort of, yeah. I mean, we did it last year.
And we're kind of doing it this year.
All right, so this left one, if you had to guess, okay, talking about its direction, its shape, and strength, how would you think to describe it?
I would call it positive, linear, and strong.
Okay. A strong, positive, linear relationship. How about the one on the right?
A negative, weak, linear.
You think it's linear?
Well, no, I just drew mine.
I think it's
kinda
kind of random.
It's curved.
It's
Curved. Okay,
I
it's
drew
got
mine
this
wrong, that's
little
why.
like arc in it.
You draw it right?
So a weak, negative, curved relationship.
It matters how you draw it, guys.
Took so much dots. I'm
Ow.
All right, the variables that go on the x-axis are the independent or predictor variables. Okay, so the ones that are changing. Okay, the response variable is the variable of interest that goes on the y-axis. Okay, it changes based on the x, okay? It depends on x. Correlation. It measures the strength of a linear association between two variables. It is a more specific definition in stats than the general meaning of correlation. Okay, because in general life, okay, we have a set of twins in here. Okay, we could say that they are correlated because they are twins. Okay, there's a correlation between the two of them, right? But in stats, we want to know how strong that correlation is. Okay, so it's a little bit of a stronger definition as well when we're talking about what correlation means in the statistics realm. Okay. So I'm going to highlight the important part. Oh, that was.
I was about to say something, but I didn't know
No, I'm just not paying attention. The correlation coefficient okay, and that's represented with the letter R.
It's
Gives a numeric value for the strength of the linear relationship it ranges from +1. Oh, wait, let me do it this way. Which is a perfect positive relationship to -1, which is a perfect negative relationship a correlation coefficient near 0 indicates a weak or no evidence of a linear association
I've never seen that color before.
I have to try to find a darker green. The lime green is a little bit difficult to
So,
see.
I meant like in the
so like associations and correlations is like how close it is to actually being linear or curved or random. So like, or in the the second picture that we drew, it was weak curved because you couldn't really see it was curved. Like you had to look really close to figure out.
Yeah, and I mean when they're drawn like from the book or something, they'll be like it'll be pretty evident. Okay, notice the correlation coefficient. Okay, something about it.
It's gonna work.
Okay. This, okay, with 1 near 0, this does not mean there is no relationship, only no linear relationship. Okay, there could be a curved relationship or something like that, but or some relationship in general, but it does not mean that it's linear. Okay. Okay, this next thing, I urge you to pay attention to what I say here about this next thing. Because I promise you it will be hilarious when I grade your quizzes and tests if you don't pay attention to this next, like, 2 things that I'm going to write. Okay?
Wait, I want to flip
I-
my notes so I can hear it.
I am. I'm just picking a color. Okay, I'm going to write the thing, but then I'm going to talk about what you actually need to pay attention to. Okay, correlation conditions.
Could this fit on like 6 slides?
Yes. Correlation conditions. I can't spell. This is a problem. Check the following. 1. Quantitative variables. 2. Straight enough scatter plot. 3. No outliers. Okay? All of these are important. Okay? But the one that I can almost guarantee someone is going to ignore is the fact that it has to be quantitative variables. What does that mean?
Has to be numbers that have a unit.
Okay,
Not
numbers, okay, not like a zip code, not a breed of dog, okay, things like that. Now, you may be saying, why is she emphasizing this? I may ask you to draw a scatter plot of something with categorical variables. What are you going to tell me?
Say no.
No, you can't do it. And then you're going to tell me that you need quantitative variables. Okay? It's hilarious when you end up with categorical variables on your plot and then you're trying to give me a correlation coefficient for zip codes. Your calculator's not going to know what kind of variables they are. So if you just plug this stuff in, it's going to say, okay, here's your graph. Then you're going to inevitably give me a graph, and then it's going to be really funny. So I'm telling you right now, you have to check that it's quantitative. It's got to be straight enough, okay, meaning it's not like all over the place like that second graph that we drew earlier, okay, and no outliers. You don't want to have like all your data lined up together and then like 2 out in Antarctica or something like that, okay? They need to all be there together. And all of these things we check by examining the scatter plot, okay? Well, the straight enough and the outliers you're checking by examining the scatter plot. Quantitative variables, well, that you should be able to look at the problem and tell. Okay, so the second 2 things you may not know until you create your scatter plot. Okay, because you could create it, but you cannot give me a correlation coefficient of zip codes or dog breeds or something like that. Okay, so these are all checked by examining the scatter plot. We have 1 page left, and then we're done.
That's crazy how like you use 3 pages. Like you just write. Like not immediately.
Yeah, well, if I was writing on my own paper, I would probably have gotten all of that on 2 page, like on 1 page for myself. But since I'm writing it, I was writing it with like the fat Sharpies too. I mean,
And it's not like on lined paper.
yeah.
So,
I think my lines are either really fat or I just have a lot or like less
let me
lines.
see.
Cause
It
like
looks like that. I kind of need to.
All right, you can calculate
I could read it.
the correlation coefficient for a set of data
Correlation coefficient.
using the linreg command on a calculator. Okay, we've used that before. You'll use it again. Okay, it'll give you that R value. You can just sit right there. The rest of them things.
Is it like linreg? Is that it? It's not like linreg AXKSP.
Either one will work, but yeah.
Like, is there a plain linreg?
Just use the one that's like number 4 or whatever. Don't use the other one. Nothing wrong with it. It just probably will confuse you. And there are ways to get like the curved one as well. I don't know if we actually, I think we just do the linear one, but there are ways to find like the curved like line as well. Which I think we did last year in Algebra 2, but I chose not to do that with them this year. All right. Couple things here that are just important. The sign of a correlation indicates the direction of the association. It's always between -1 and +1, but rarely exactly -1 or +1. The correlation is the same for x to y as y to x. Correlation has no units. Okay, it is just a number. It is possible for variables to have, or variables can have, a strong association but a low correlation value if the relationship isn't linear. Correlation is sensitive to outliers. Okay, by putting in one number that's an outlier, it can completely change your correlation coefficient. By typing a number in your calculator wrong out of the list can change your correlation coefficient. Okay, one number can change it. Okay, now if you have a ton of numbers, you know, like 40, 50 data points, one number being a little off may not change it that drastically, but they all will be affected by changing a number, adding a number, having a number that's an outlier. Okay, so sometimes when we do this, we will decide that we are going to ignore outliers, or we're going to point out that it's an outlier and then we're going to remove it. Okay, or we'll remove it from the data set when we're finding our correlation coefficient, but we'll still plot it on the scatter plot. Okay, so just be aware of that. Okay, as we get problems that have that, we'll talk about what that looks like and all of that, but just a heads up for that. All right, something else that is key to mention: correlation is not equal to causation. Like you have a cast on your foot because you broke your ankle. That would be causation. But correlation could be something like, oh, you have a cast on, you must have gotten injured, kind of thing. Like it's, kind of, yeah. Correlation's more, I mean, sometimes they are the same, I swear this thing's on Do Not Disturb. Sometimes they are the same, but they're not always the same. So don't assume that they're equal. We can only, okay, along the lines of that, we can only describe association by saying increased variable x is associated with increased, decreased variable y. Be aware of lurking variables.
How can a variable lurk?
So these are things that are not relevant but could affect it, or things that are mentioned that aren't relevant to it. Okay. It's kind of hard to just come up with one like on the top of my head. I don't know. We'll have to wait till we get to an example. I can't think of one at the moment. I'm like blanking on it at the moment. So, all right. So I'm going to give you kind of what a good correlation statement would look like, and then what we can't say, okay, about the same thing. All right, a good correlation statement. There appears to be a strong, positive, linear correlation between hours studied and test scores. Students who study longer tend to have higher scores. Okay, so that would be a good statement. So if I ask you at the end to explain what the correlation that you found means, something like this would be what I'm looking for. Okay, you've got to talk about weak, moderate, or strong. You've got to talk about positive or negative. You've got to tell me if it's linear or not. Okay, I want to see those things in there, and then maybe explain why you've concluded that based off of what you see. Okay, being the students who studied longer tend to have higher test scores. Okay, but, okay, again, correlation is not equal to causation, so that's a correlation statement. We cannot say something like, don't assume causation by saying if a student studies for more hours, their score will increase. Okay, you can't assume causation. We can't have causation in there. Okay? So I've got example sheets for us for the next probably 2 days that we'll be going over. I think most of y'all have colors, but I do tend to use colors a decent amount. Yeah, so anyways, just be ready for that. And yeah, we're done for today. I can't talk for the day.